And again, welcome to today's webcast, Scaling on AWS for the first 10 million users. Our presenter today is Chris Munns. Chris is the AWS Certified Solution Architect. He has worked both in the physical and cloud data center environments. Chris has many years of experience setting up and managing web application servers, database tuning, application design, firewall configuration, monitoring and metric collection and analysis, backup, and disaster recovery. So Chris, you have the floor.
Great. Thank you, Bowen. And thank you again, everyone, also for joining us here today. So as Bowen just mentioned, my name is Chris Munns, and I'm a solutions architect at AWS based in our New York City office. Generally here today, hopefully you're here to learn a little bit more about scaling infrastructure on AWS. And today's really going to be about some best practices and things to think about. It's definitely not a definite blueprint or the only way to get things done, but it's really just for help you get some general ideas of best practices and the types of patterns and that you might see as you're building out an application on top of AWS. So obviously, when you're looking at building in the cloud, you're usually looking to make use of economies of scale and the ability to scale elasticity and handle large amounts of data or traffic or load, whatever it might be in your application. And so we find ourselves early on asking is, how do we scale on AWS? What's involved? Obviously, cloud is a little bit of a change compared to those of us who are used to working in traditional data centers on physical infrastructure. Even if you were doing virtualization inside of your own data center, it's still quite a different look and feel to building in the cloud. Plus here at AWS, we do have some other services that can help you scale faster, both in terms of managing and then also in terms of application services. And so we're going to try to cover some of that today. For a lot of us, though, starting out in AWS, especially if you're starting out new, it could be kind of confusing as to where to start, where to go, what you should be thinking of first, and what your priorities should be like. So let's say that you're a new customer to AWS. You're looking to build out a web application, and you want to figure out about how you could scale on AWS. For many people, your first step is your favorite search browser, or search engine, and you're typing something like scaling on AWS. If we were to type this in right now today, we'd get back quite a lot of results, almost 1 million of them today, maybe a little bit more. This might be a little bit dated. But the first one that comes up right now today, at least in terms of what Google spits back at us, is Autoscaling, which is one service that we have here at AWS. And while it's a very important service at AWS, this is not necessarily the general starting point for scaling on AWS. There's a lot of other things that we need to get out of the way. And so while you could think of Autoscaling as more of a tool and a destination that you want to build on, it's not the kind of thing that you can just point and click or drop it in place and all your problems are going to be solved. So that leads us to asking, what do we need first? If just going and turning on autoscaling isn't the thing that will solve all of our problems, where should we start? So I always like to start with some basics. The most basic of things with AWS is actually at the physical level. So we have a concept at AWS called regions. Currently today there are 9 of these around the globe. One of them is our GovCloud region for government customers in the United States. The other 8, though, you could use pretty much interchangeably around the world. And the idea here is that these regions contain usually all of the services that we have, all the features that we've launched at any given point in time, potentially with some delay as new services come out. But you should be able to run your infrastructure the same in US East or Virginia as you would in South America or as you would in Singapore or as you would in Sydney. Diving a little deeper inside of those regions, we have another concept called availability zones. You can think of availability zones as individual plots of land that Amazon has where we have data centers that are inside of a region, with the idea being that when you build an application on AWS, you want to be making use of multiple availability zones inside of a single region. There's definitely patterns and reasons that you might want to go multi-region, but at least for most of today's conversation, we're going to be focusing on single region deployments, making use of multiple availability zones. And we have a number of services that will automatically span availability zones for you. We have a number of services that have built-in redundancy and duplication of data. And so we'll be talking a little bit about those a little bit more in detail as we go through the talk today. To help set some of the scope for the size of AWS, this is a question we often get asked, and we don't necessarily disclose all of these numbers. One fact that we do like to bring up is that back in 2003, Amazon.com, or siblings on the retail side, they were a $5.2 billion business. They had almost 8,000 employees globally, and they had a whole lot of servers. It was, even back in 2003, an incredibly popular website to buy all sorts of different things on. Looking at AWS today in 2013, every single day we add enough capacity and storage to have powered Amazon.com back in 2003. So every single day we are constantly adding new capacity, constantly adding new storage. And so the thought is that it should be nearly impossible for you to outscale what is capable of being built on top of AWS, especially as we continue to grow our footprint globally. When we talk about the services that make up AWS, there's a couple of main categories that we have: deployment administration, application services, the three main blocks that we have, which are compute, storage, and database, built on top of our networking layer, and then we have the AWS Global Infrastructure, which are the regions and availability zones that we were just talking about a few minutes ago. The way it gets broken out in the console, the web console that we have that you can use to access these servers is a little bit like this. There's about 26 services that we have listed here, I believe. I'm not going to go through all of these today, but I guess the idea here is just to explain that there's a lot of different services and a lot of different components that you can use in building out your applications and your infrastructure on AWS. And sometimes you may not think about all of the different points and places where they could help you out, but I really definitely recommend that you investigate each of these a little bit further and get a good understanding of how they might potentially help you. So getting back to our application for today that we're going to talk about, we're going to be discussing a fairly straightforward web application. It could be a blog or an e-commerce site or some sort of a media site, something that users would interface with. We're going to be storing some user data. We're going to be serving out some content. And the concern here is that we are an increasingly popular application on the Internet, and we need to deal with scale. So starting from day one, user one, you the developer or creator of this application, pretty straightforward, standard kind of early setup. You have a single EC2 instance where you'd be running the full stack on this host. So that is the web app, the database, any management tools that you might have, everything on this one instance. We're going to attach an elastic IP to it, which is a static IP address that you would assign to this EC2 instance. And then we're going to reference the DNS for our example.com or whatever it might be in Route 53, which is a global DNS service that we have here at AWS. And so with this, you could quite possibly serve into the hundreds, if not maybe thousands, of individual users that might be using your website. And the real simple way to scale this would be going to a larger EC2 instance. So we have a number of different EC2 instances at AWS here, over 15 now today that you can select from, with all sorts of different characteristics to them. Going up the ladder in higher CPU and higher memory and higher disk storage. And then beyond that, we have some specialized instances that offer you things such as high I/O, instances that are backed by SSDs, high memory instances, high CPU instances, high storage instances. And it's pretty easy for you to be able to change instance sizes with your application and continue to scale up horizontally by using or vertically by using a larger host, but eventually you'll hit an endpoint. At some point you'll have been on the largest host that we have at a given point in time, and so scaling up isn't really going to get you much further than that point. So the other things that you would have to think about is that in this setup right here, we have no failover, we have no redundancy, and we really have too many eggs in one basket. So even though we could scale to a few hundred to maybe a few thousand users, we still got a lot of concerns about the ability for this instance and this architecture to handle any sorts of failure and to potentially scale beyond this individual single host. So the first logical step is to break out our web and our database tier, our application and our database tier. And so in doing this, we're going to add in another EC2 instance, and we're going to run our database on it. But instead of adding another EC2 instance, what if we were to make use of a database service? So the first collection of services I'm going to talk about here today are database options that we have at AWS. So the first one, obviously, is that you could self-manage on an EC2 instance, handle all of the configuration, run pretty much any database software you could think of, from MySQL to Oracle to SQL Server to DB2 to Postgres to any number of NoSQL offerings. You could, if it installs on Linux or Windows, you could pretty much run it on an EC2 instance, no problem. But beyond that, we have a number of services that are more or less fully managed to take away some of the load of you having to do this yourself. So the first is Amazon RDS, or Relational Database Service. This is a database offering that we have that supports 3 different engines: Microsoft SQL Server, Oracle, or MySQL. And what we do is we help take care of a lot of the kind of low-level heavy lifting involved with dealing with a relational database. So things like nightly backups, easy ability to scale the physical resources of the server, so CPU and RAM and storage, the ability to do configuration management in terms of how you configure the databases, the ability to do snapshots, patch management, viewing the logs that come off of these databases. And so there's a lot of tools that are built in to help make your life a lot easier when managing a relational database. The next service that we have is DynamoDB. This is a managed NoSQL database service that we have. It's built on top of SSDs, so it's meant to be, lightning fast, incredibly low latency, incredibly fast replies to queries. And with Dynamo, there's almost zero administration. You literally just tell it the number of reads and writes per second that you want to be able to handle, and the service behind the scenes handles any sort of replication of your data, duplication of your data, scaling out of storage, scaling out of the ability to reply to queries, and there's really nothing that you have to do to it. You just tweak it to what you need it to be, and it handles all the rest behind the scenes. And then the last service is something that we came out with earlier this year, Amazon Redshift. It's a massively parallel petabyte scale data warehouse service, giving you the ability to analyze large queries of data in structured columnar format. And with Amazon Redshift, again, much like the other ones, you throw your data into it, and you have the ability to query against it. And as your data grows, Redshift can scale with you into very large scale, again, petabytes of storage available and many processing cores to handle the largest queries that you could think of. So the next question is, we've got a number of different options, right? We've got SQL options and NoSQL options, some that are hosted and available by us here at Amazon, some that you could bring yourself and run yourself. How do you go about choosing a database technology for a new application? And it's definitely a conversation that requires a lot of time and a lot of investigation into how your application is going to work. And it kind of borders sometimes on the lines of a religious conversation. And so some folks may not like this answer, but our recommendation is that you start with SQL-based databases. And right now I know there's a lot of other people that are listening on the line here watching this, and they're saying, but, I have a good reason not to use a SQL-based database. Fortunately, more often than not, you don't. So our advice, again, here is to start with SQL databases. So why start with a SQL database? Well, it's well-established and well-worn technology. SQL's been around for a long time now, bordering on probably 30-plus years. There's lots of existing code, communities, books, people that have background and tools that can help you build and tune your applications and your infrastructure as you're scaling. You're also not going to break SQL DBs in your first 10 million users, really. Again, and there's a little asterisk here, unless you're doing something super weird with the data or you have massive amounts of it, even then, more likely than not, SQL will still have a place in your stack. The other thing, and we'll discuss this a little bit later, is that there are really clear patterns to scalability. You're not reinventing the wheel. Some of the largest organizations in the world are built on top of SQL. Some of the largest websites that people deal with every single day are built on top of SQL. And so it's definitely a recommendation that you look at this technology as something that should be a foundation of what you're building a large-scale application on top of. So again, going back to this asterisk here where I say, there are some potential exclusions or reasons why you might not want to go with the NoSQL. The first one that everyone says is, oh, well, we're talking about scaling to a large size, and you said that if I have massive amounts of data, then maybe I'm an exclusion into this. And everyone says I will have massive amounts of data. I think it's important to kind of quantify what that, quote-unquote, massive amount of data might be. So what I like to define it as is if your usage is such that you'll be generating several terabytes in the order of 5 or greater of data in your first year of an application, or you have an incredibly data-intensive workload, kind of workload where you're analyzing regularly millions of rows in your application, then you might need NoSQL. But again, what I found with working with many customers over the last couple of years working at Amazon is that this is probably less than 90% of you. So you really want to take some time to think about what databases you're choosing for your applications, why you're making those choices to use them. There's obviously a lot of marketing and attention that goes into companies that make database software to try and promote their offerings. But you should really take the time to take a look at how your application interfaces with the data. Is it a relational workload? Is it something where you're really truly going to have massive quantities of data? And if not, you probably want to stick with a SQL-based database. So moving back to our architecture here, let's say that we have made the decision to go with RDS, potentially MySQL, I guess we'll say in this case. And so we've decided to go with RDS, and we still have our single web instance. So we've taken care of splitting out the web and the database load, but we really yet haven't addressed any of the failover or redundancy in our application. So taking what we have here and moving on to addressing that, the first thing that we're going to do is break our application into a multi-AZ setup. So what I've got here on this slide outlined in the dashed orange marks is representing two different availability zones inside of a single region. And so we've now added a separate web instance. And in using RDS, one of the capabilities of it is the ability for you to have what we call a multi-AZ setup, such that you have a primary instance in one AZ, you have a standby in another AZ, and if at any point in time the primary were to fail or we lose communication with it, the service will actually swap over the connection point to the standby, and your application should have to do nothing in order to start talking to the standby. So very quick failover, completely painless for your application in terms of you needing to make any changes, and your infrastructure continue to run, and you should be able to continue to serve traffic. The other thing that we've added to this topology here is an elastic load balancer. And I'm going to talk a little bit further here about elastic load balancing in AWS. So ELB, elastic load balancing, is a service that we have that allows you to create a highly scalable load balancing tier inside of your application. And we have the ability also now inside of virtual private cloud, VPC, the ability for you to do internal ELBs in between your different tiers of your application stack. The idea here is that an ELB can span multiple AZs inside of a single region and serve any incoming traffic that you have to that ELB down to any hosts behind it, such that if any of the hosts behind it, any of those web instances were to fail, the ELB will know to just serve traffic over the ones that are still healthy. And so it does this via having health checks of the instances that are behind it, and has the ability to pull those instances out in case they are failing. It also has the ability to do things such as session stickiness, to do SSL termination, and it also provides you a number of different metrics back against your infrastructure. And so with ELB, you literally just provision it, point instances behind it, and it takes care of any sort of scaling or healing of the ELB layer that needs to happen. And so we have customers that are doing tens, if not hundreds of thousands of requests per second through ELB without having to worry about managing the load balancer layer themselves, without having to provision, say, multiple load balancers and scale them out. ELB takes care of all that for you. So again, another service that's meant to be very light in administration, but is very, very capable of handling large amounts of traffic, of self-healing itself and self-scaling itself. So now that we have ELB and we've got RDS kind of doing its thing, we could scale this horizontally and vertically again, using larger instance classes, and get pretty far, to the tens, if not hundreds of thousands of users. So if we were to look at this topology again here, a little bit more expanded out, we have our user that's using Route 53 or communicating with Route 53 to get the DNS records for our website, which is going to serve back the IP addresses for our elastic load balancer. Behind the elastic load balancer is going to be our web tier. So in this case, we're currently showing 8 web instances. And then behind those 8 web instances is our RDS database tier. So in this case, what we're seeing is a master and a secondary, and then a whole bunch of read replicas, which is another capability that RDS has built into the platform, is the ability to fire up read replicas. So again, with this, we can honestly get pretty far. We'd be able to serve quite a bit of traffic. There's quite a lot of redundancy and failover, and we could definitely scale quite a bit. And that's actually probably the most basic topology that we see most of our customers at an early beginning scale take. And so this will definitely take us far, but if we care a lot about the performance and efficiency of our infrastructure, there's definitely places that we can clean this up. So looking back at the web application layer and the database layer, there's a couple of things that we can do very easily to help give us quite a performance boost in this application. First thing we're going to want to do is move any sort of static assets from our web server or servers off to something that would serve that better. So move the static content, say your CSS files and your JavaScript files and your image files, off to something like S3, our storage service, and then put CloudFront, our CDN service, in front of that. What that's going to give you is a highly durable, highly scalable storage service where your data is going to be located. And we'll go into a little bit deeper about S3 in a minute here. And then fronting that with Amazon CloudFront, a content delivery network that has global presence and the ability to serve up content to your end users much quicker. And so in doing that, you're going to lift an incredible load off of your web application. Often it's found that static assets are often sometimes 80% or more of the traffic that might be coming off of a web server and going to an end browser. So this will definitely lighten up the load in terms of network utilization on these hosts. The next thing we want to look at doing is lightening up both the application and the database further via doing some sort of caching. So this could be session caching, it could be cookie caching, it could be database result caching, and there's a number of different services that can help us with this also. One is a service called ElastiCache, which we'll go into a little bit further here in a moment. The other one is DynamoDB, which you've already lightly covered today. So in moving some of this workload from the web instances and also from the database tier, we can actually significantly lighten up the amount of memory and compute that's being used by centralizing these in these tiers. So in diving a little bit deeper on S3, again, this is our simple storage service that we use, that you can use to store objects in the cloud. So it has 11 nines of durability, and it's good for things, again, like static assets, backups, logs, ingest of files for processing. And we like to say that it's infinitely scalable. When we talk about what that means, back in April of this year at our New York Summit, it was actually announced that at that point, Amazon S3 held over 2 trillion objects and was processing 1.1 million requests per second. So this was several months ago. I know this stat is already dated, but you can see that even going back to April, there's quite a lot of data that's stored inside of S3. It's quite a large-scale service. And so you should feel comfortable putting your objects that are going to be served out to your end users in S3. S3 also has a lot of great features of things like fine-grained permission control, so the ability to control who can see what objects, who can modify them, who can delete them. Again, it ties in very closely and very nicely with CloudFront, our CDN service. It also ties in with EMR, Elastic MapReduce, which is our hosted Hadoop service, a service that we're actually not going to be talking too much about today. It could also act as a logging endpoint for both itself, CloudFront, and billing. Basically, with S3 CloudFront and our billing abilities, you have the ability to get logs of access to S3 CloudFront or what you've spent over an hour or a day or a month put into an S3 bucket. It also supports encryption at transit and at rest, which is a very useful thing. It also has another kind of flavor to it, which is called reduced redundancy mode, which is a third cheaper and has a little bit less durability than the full version of S3 does. And then lastly, there's another kind of version of the service called Glacier, which is an archive service that we have, which is really, really useful for long-term storage of things that you would potentially not be accessing but need to keep around for potentially regulatory reasons. Next service I want to talk about here again is DynamoDB. And so I gave you a brief on this a little bit earlier. Again, it's a NoSQL database built on top of SSDs. It's meant for really fast, predictable performance. And in our application stack here, this is something that we could definitely use as a caching tier. So potentially, again, storing things like session information. In an e-commerce site, maybe cart data, or maybe some sort of other transient data that hasn't been fully committed yet to our relational database. Again, with DynamoDB, you literally just dial up and down the read and write capacity that you need, and behind the scenes it takes care of all of the provisioning and all of the scaling and all of the redundancies that are based into Dynamo. DynamoDB, much like S3, are two services that are multi-AZ by default. So you never have to worry about what AZ they're in. They automatically have their data replicated across them, and you just talk to the common endpoint, and the service figures out how to direct you to get your data. It has strong consistency, so when a record is written into the database. You know that when you request it, you will get back the most recent write. Again, it's highly fault tolerant. There's a lot of built-in monitoring with our service CloudWatch, which is our metrics and monitoring service in AWS. It's very secure. You can control access to it with IAM, or Identity Access and Management. And this also, much like S3, ties in with EMR, or Elastic MapReduce, for analyzing large data sets that you might have stored there. The last service I'm going to touch on here is Elasticache, which is a service that we have right now that currently supports the Memcached engine, and it speaks the same APIs as the traditional open source Memcached. It's pretty much just hosted Memcached with some really awesome stuff put on top of it. What you do with Elasticache is you provision it as a cluster, and so that could be from one to many, many nodes. What an Elasticache cluster will do for you is it's self-healing. So if any instance were to fail, it will automatically replace that instance. Again, currently with using Memcached as the engine, it's very, very fast, potentially single-digit millisecond speeds, or potentially less depending on the size of the instance and the amount of data or requests that are going to it. So it's very, very useful for being a light caching tier in a web application where you're either caching, say, database queries or session information or any sort of other temporary information that you might need to. We've also built out an auto-discovery client in a couple of different languages that help you with when an instance dies and then is replaced, you won't have to necessarily hard code that host's information into your application, which is really, really great for helping you build very highly durable applications. So now that we've shifted some weight off of our web and database tier, primarily our web tier here, by moving static assets off to S3 and CloudFront, by moving some application caching off to either Elasticache or DynamoDB, we can actually go back and revisit what we talked about at the beginning of this talk, which is autoscaling. So again, autoscaling, not the place where you want to look to start when you're first building your application, but definitely something that you want to build to once you've gotten to the place where you can lighten up some of the other tiers of your application stack. So autoscaling is a service that is built directly into EC2. It's very easy to configure. It's very easy to set up. And what autoscaling will allow you to do is to scale horizontally the number of instances that you have representing any single pool. So it's not going to help you go from an M1 small to an M1 extra large, but what it is going to do is help you go from 2 M1 smalls to 20 M1 smalls, back down to 14 M1 smalls, or whatever it might be based on the traffic that you have. And so there's a number of different ways that you can set up the policies or the triggers for doing the scaling. You could do it based on some sort of a metric that is in CloudWatch. You can do it based on a schedule. So maybe you want to launch a number of instances at 6 a.m. and turn them back off at 12 a.m. Or there are manual triggers that you can set up. So you have the ability of within, say, your own application or your own monitoring to just call the API or the command line tool to initialize a scaling up or scaling down action. One of the other great things about autoscaling is that it's built into our notification service, SNS. So you can actually take notifications from autoscaling actions, again, a scale up or a scale down, and then use that in further automation in your own systems. So where is autoscaling useful? If we were to look at typical traffic for a week at Amazon.com, Sunday through Saturday, it might look something like this. And this pattern might look very similar to the applications that you might be running with your own websites. And so it's actually pretty easy to provision capacity for this. We can take a line, draw it above, say, 15% what we think peak capacity is, and actually be pretty good in our utilization given the provision capacity that we have here. So if we did want to statically provision resources, we could do this and probably be pretty good for this week right here. However, it changes a little bit for Amazon.com when we go to November, and at the end of the month, there's some serious spikes as we go into the holiday season in traffic. So if we were now to draw a line at 15% above peak utilization, there would be a massive amount of wasted compute if we were provisioned ahead of time to handle the end-of-the-month load. And traditionally, if you were working inside of a data center and you had maybe, say, yearly hardware purchases, you would be making these same kind of guesses. You would say, okay, we're going to draw a line at 15% above what we think we might need, and you provision that capacity and order that and have it racked and powered and spinning, but you might have a lot of wasted capacity going into that time frame when you actually need it. So what autoscaling allows us to do is take this blue line and match it exactly to our traffic. And again, that could be done via, say, CPU load on the cluster, latency off of the load balancer, network traffic coming in and out of the environment. And so, again, we can really, really finely tie in the amount of resources that we need directly to the amount of resources that we really need here based on traffic. So again, autoscaling lets you do this. And it's definitely the kind of thing that you want to look at once you've taken care of some of the things we talked about earlier in terms of lightening up your web application and making sure that you could handle things such as the tear down of an instance as part of a scale down. So given that we've added in autoscaling, there's still further improvements that can be made to our web and our application layer. So one of the big concepts that we talk about at AWS, and something that is very prevalent inside of both Amazon and AWS, is service-oriented architecture, or I like to call SOA all the things. So in SOA in your architecture or your infrastructure, what you're looking at doing is moving services or components of your application into their own tiers or modules. So treat every single part of your application as its own piece of infrastructure, as its own little mini application, which will allow you to really scale them independently, fix bugs that might be in between them, move forward in development and launching new features without having to worry about having the entire application stack follow with you. And this is something that is done very extensively, again, at Amazon.com and AWS. If you ever use the service EC2, which we all hope you will, underneath the hood of EC2 are several dozen mini services that pin together and make the service work for our end customers. So in terms of doing and building service-oriented architecture into your own application and infrastructure, loose coupling is really one of the key concepts that helps set you free and be able to do this really well. So again, loosely coupling the different parts of your application, providing potentially individual interfaces or some sort of common communication plane between them is what will allow you to really, really scale up and deal with a lot of traffic or deal with a lot of data. So again, think of these all as independent components. Try to design every one of them as a black box. No two components should have to know too much about the other outside of some sort of common interface that they use to talk with each other. Try to decouple interactions wherever you can. And try to favor services that have built-in redundancy and scalability instead of building your own. And we'll talk a little bit about that in a minute here. Again, as an example here, we show, let's say that you had to pass data between two different services, controller A and controller B. You could take data in to controller A and then send it directly to controller B, but if there was a failure in any one of these components, what might go wrong? Would you lose data? Could you potentially overwhelm another service? Could you starve controller B for resources? And so you might want to think of putting something, say, like an SQS queue in between two different parts of your application to help handle any sort of overflow or failures that might happen. And SQS is a service that we have, simple queue service, that very high-scale queue service that you could use for, say, buffering information or for worker workflows or anything that you might do with a queue. So again, loose coupling and SOA will really help set you free and really help you win in terms of scaling your infrastructure. And in the early days, if you're building out a new product or you're building out a new company, you might want to try to avoid building components that other people already have out there for you, reinventing the wheel on some of these things. So there's a number of services that we provide that can help you out. I have 6 of them listed here. Amazon SNS, which is our notification service, which we actually just launched the ability for you to do mobile push notifications to iPhone and Android devices. Amazon Cloud Search, which is a hosted search platform built on the same technology that powers the Amazon.com search toolbar. Amazon SQS, again, a queuing service that we have, very highly scalable, very high durability built into the service. Amazon SES is a simple email service. This is a service for sending email outbound potentially to your customers, and it can handle millions of emails a day, very high scale, very high throughput. Amazon Simple Workflow is a workflow management service that you could use in building and actually helping with some of your SOA infrastructure. And then lastly, Amazon Elastic Transcoder. If you're doing any sort of transcoding of audio or video files, Elastic Transcoder is a very simple drop-in service to help you take in audio or video in pretty much any format and output it again into multiple formats to be digested by your users. Other examples of things you might want to look at, separating out and opting for a build service instead of building your own, things like databases, monitoring tools, metrics tools, and logging tools. These are the kind of things that you really shouldn't be building yourself. Which kind of leads to my next point here in this presentation, and this is something that I have run into many, many times in working with lots of different customers, is that if you find yourself writing things such as your own queue, or your own DNS server, or your own database server, or your own storage system, or monitoring tools, my recommendation is that you take a deep breath and you convince the developers in the organization that are doing that to stop it now. Again, this really is the definition of reinventing the wheel, and more often than not, I find that people are either not exploring current things that are open source or available from third parties that are probably going to solve the exact same issue that you're looking to solve yourselves. So getting back again here to SOA, let's imagine that we had a feature on our website that allowed our users to upload photos. So maybe it's a mobile device, maybe it's a browser, but somehow they're going to be sending us photos. And then we're going to take those photos and then resize them such that they can be served back out in some sizes for different media. So again, maybe served back out to mobile or serving back out to a browser or something similar. So looking at this example architecture here that we have for this process, again, we have our end user, and they have uploaded their image, and so we've put that directly into an S3 bucket that we're going to use for ingest. And then part of the application is also going to send or queue up a message into an SNS topic. And then SNS has the ability to have multiple listeners off of a topic, so it's going to push out that message to 3 different queues that we have. One queue for thumbnails, one for the image for mobile devices, and one size for web devices. And again, these queues here are almost infinitely scalable. I've seen customers with tens of millions of objects in a queue. And so we can continue to write these in. And then behind these queues, what's going to be pulling them is a group of hosts inside of an autoscaling group running our image resizer application. And so with this, we can have 3 or more, however many different sizes that we need to make, all being sized by independent pools. And each of these independent pools could potentially have failures at any point in time, could be taken down, could be changed, without us having to affect the rest of the application. And so in its heart here, this is exactly what SOA is about. We've got loose coupling between the different parts of our application stack. We've got the ability to handle failing of any single component without it tying back to any other component in the application. And we're also making use of highly redundant, reliable, self-healing services, such as autoscaling, SQS, and SNS. And then we're taking our data after post-processing, tossing them back, the originals, into a regular S3 bucket, tossing the resized into a reduced redundancy mode S3 bucket, which we could then serve back out to CloudFront. And with this, we can handle a very large throughput, potentially tens of thousands, if not hundreds of thousands of images per day, maybe even more than that. And this is a very common pattern that we see for this type of a workload. So in putting this all together here and reaching, let's say, our first 1 million users that we're going to have of our application, multi-AZ, obviously a really key component in building in redundancy and scalability in our application. Using Elastic Load Balancer between tiers, another very important thing, the ability to have these kind of self-healing, self-balancing parts of our application across availability zones. Making use of autoscaling, again, when you're ready to, when your application is ready to help you match the capacity that you have running at any point in time to the needs of the application, based on traffic coming in. Looking at building out a service-oriented architecture, really taking our application stack, taking all the components, all of the different flows, and breaking them out into their own individual services, their own little mini architecture stacks. Serving content smartly. Again, you really shouldn't be serving static content from a web server these days. This is exactly what S3 and CloudFront are there for. Moving caching off of the database. In-database caches can often be pretty painful and pretty slow and not worthwhile at large scale. So again, look at making use of a service like Elasticache or DynamoDB to help cache some of the things that are coming off of your database. And then the last thing here, again, is moving state off of tiers that autoscale. So anytime that you have a tier of your application that's going to be autoscaling, whether that's scaling up or scaling down, you want to make sure that you're not storing anything on those instances that would be bad if you lost. So any sort of stateful information, things like log data, assets that your users might be uploading, assets that might be kept in your application, look at putting those also into a caching tier or into a static object store like S3. So a quick glance here again at what this architecture might look like. In this case, I'm breaking it down just to one AZ here. And so what you see is, again, inside the orange box would be potentially doubled up to represent the other availability zone that we would have, or availability zones if you had more than two. So again, we have Amazon Route 53, our DNS service, directing traffic either to a load balancer or to CloudFront to serve up our assets. From our Elastic Load Balancer, it is going to be pushing traffic down to the web instances that are attached to it, which we've now put inside of an auto-scaling pool. We've moved some sort of application caching needs off of the web instances to Elasticache. So that one cache block could represent an entire cluster of Elasticache nodes storing in memory things like session state or cart data or something similar. We're still making use of RDS. In this case, I'm just showing the master, but you could assume there would be a standby in another availability zone. And we're still making use of read replicas. And then moving off to the right a little bit further here, we've got our worker instances that are talking to an Amazon SQS queue. And maybe we've got some sort of internal app instances that are also in this environment, also in an auto-scaling group. And then we're making use of services such as DynamoDB or Amazon SES. Again, self-healing, self-scaling, kind of set it and forget it services that you don't have to do a lot of management on and that can handle a large amount of scale with very little oversight from the user of those services. So what are some of the next big steps, right? We've built quite a lot into this application stack here. It's pretty decently complicated. But what are the first things that you're going to start running into as you're scaling this out and you're trying to get into the 5 to 10 million user range that we're talking about today's talk? Well, you'll potentially start to, at some point here, run into issues with your database around contention on, say, that master database that we have. So let's say that you've already gone and you've scaled up to the largest instance possible and the most amount of tuning that you can do and the most amount of storage. How would you get around solving that issue? A couple different options here. The first one you usually see people do is federation, or splitting the single database into multiple databases based on function. The next option is sharding, so splitting one data set up across multiple hosts. Or you could find that you need to move some functionality into other types of databases, potentially a NoSQL database. So talking about federation, again, a very common database scaling technique here. We're taking our one single monolithic database, we're going to split it up into different functions. So in this case, I'm giving the examples of taking our master DB and splitting it into a forums database, and a users database, and a products database, which would then give us the ability to scale each of these databases independently of each other. Again, kind of moving closer towards an SOA architecture for our databases, such that we don't have to worry about, let's say that our website was very, very heavy in forums. We wouldn't want the forums traffic negatively impacting the users database or products database traffic. So again, gives us the ability to break this up and scale it independently, but then it becomes a little harder to do some cross-function queries. Joining across multiple databases or multiple tables and multiple databases becomes something that you have to push up more into the application layer as opposed to doing it in the database layer. But it could essentially delay the need for you to do things such as sharding or NoSQL until much further and much higher capacity. But one thing, obviously, is that it won't help you with single huge functions or tables where, again, once you reach the point that you're back at the largest instance and the most amount of read replicas, what do you do after that? And so some people will actually completely skip over the federation step and go right into sharding. So again, here in sharding, we're taking our single data set that we have, and instead of breaking off by function, we're taking the entire data set and spreading it out across some number of databases. So some users are going to be on shard A, some are going to be on B, some are going to be on C, and so forth. And so would be the same for any type of data that we had in our database. So this becomes much more complicated at the application layer. And so you're probably going to be leaning on some sort of ORM to help support those database queries and that database knowledge. But what's nice is that there's potentially no practical limit on scalability. Sharding is something that a lot of very large-scale organizations do. Companies such as Flickr and Instagram and Pinterest and Etsy and to a degree Facebook and Google all make use of some sort of sharding horizontally to help them store massive quantities of information. There's definitely some operational complexity and sophistication that you're going to have to deal with. But again, it's the kind of thing that once you've worked out some of the kinks, you could actually have a little bit more peace of mind that it's easier to shard out your database and continue to scale that out horizontally. And you're going to be looking at sharding on some sort of a function or some sort of a key space, again, very much application specific. And sharding is something that could be done in a traditional relational database or potentially by a NoSQL database. And so other things that you'll potentially run into at some point is that you'll potentially start to run into issues with the speed and performance of your applications. So you'll want to make sure that you have really strong monitoring and metrics and logging in place. Again, if you can't build it internally, look at outsourcing it. This is definitely the kind of space where there are a lot of really wonderful third-party tools to help you from a very small scale get started. A lot of great companies out there that have very easy pricing baked in to help you move forward. And you also want to be paying attention to what your customers are saying works well versus what doesn't. Right? Are customers complaining about your forums page is being slow, or the user customization page is being slow, or maybe the checkout process is really slow? Gathering that kind of feedback from your customers, that kind of feedback, is really, really valuable in helping you decide on what to focus on when you're looking to scale an application like this. And you really want to try to work on squeezing out as much performance from every component or service that you could. So just an example here of some of the most kind of important metrics I feel that people need to look at. Host level metrics, definitely important, but not the kind of thing that you want to spend too much time focusing on unless you're really trying to troubleshoot individual components in your application. Much more important are probably the aggregate level metrics, so looking at metrics that go across an entire pool of hosts, let's say the entire web tier or the entire caching tier or the application tier. How is CPU performing overall in that cluster? How is latency of your service on that individual pool behaving? And these are the types of things that you would normally key off, say, autoscaling based off of, is the performance of those aggregate level metrics. Equally important are things like log analysis. Your applications today are definitely going to be generating lots of logs. Spend the time to get a good log analysis tool. Often there's needles in the haystack that you're looking to dig out, but those needles could be extremely important in terms of understanding what's going on and what might be going wrong with your application. And then lastly, this is one that I'm always really surprised to find people skipping, is external site performance. What are your users actually seeing? While it's definitely important for you to know internally how your app hosts are performing and how your applications are performing, what is the actual end user experience? What are they seeing? And are you tracking that and graphing it out properly? So these four graphs that I have here, the top two are actually from CloudWatch, again, our metrics and monitoring service. The one on the bottom left here with the log analysis, this is from a tool called Kibana, which ties in with another log tool called Logstash. Great open source tools, really, really flexible. And then on the bottom right this is a graph from the website Pingdom, which is a third-party performance tracking site for web applications. All good, easy places to get started, and something that you should definitely spend time on if you're building your applications on AWS. And what I really like to say is that not having proper monitoring or metrics in place is like flying a plane with an eye mask on in a thunderstorm, and the co-pilot tells you your wing is on fire. How do you react? How bad is the fire? What wing is it? What are you going to do? You can't make these kind of decisions in terms of scaling or building your application without having some of these tools in place. And so while we ourselves here at AWS don't necessarily have a whole lot of applications to help you do this, what we do have is some really great partners and third parties that work with us and that integrate tightly with the platform. You can actually find a lot of these on our marketplace, which you can find at aws.amazon.com/marketplace. Marketplace is a site that we have where you can find and research and then buy software to use on AWS. A lot of these companies that are listed there have also followed our pricing model, so pay for what you use, potentially pay just on an hourly basis. Lots of flexibility that will help you in using these tools and making them cost effective for you as you grow and scale your business and your organization. A lot of them have built right in the ability to launch in just minutes from when you find what you're looking for. And again, hundreds of different products across 20 plus different categories. So I really encourage you to take a look at the marketplace and see what's listed there. So moving forward now to, still dealing with getting above, the 5 million mark to the 10 million users here. Managing your infrastructure also will become an ever-increasing part of your time. Managing infrastructure at scale is definitely a challenge. I've seen it personally myself in managing environments that have hundreds of server instances running. That takes up a lot of time. It's definitely going to require some dedicated staff on your part to take time and to care for this environment. What I definitely recommend is looking at different tools to help you out with this though. So tools to help manage AWS resources, tools to manage software configuration on your actual instances, and then different tools to do things like automated data analysis of your logs and your user actions and other things that might be going on. Some of the tools that I mentioned before could definitely help you with this third category here. In terms of tools that can help you with managing your AWS environment, there's a number of different tools that we do have that are really, really helpful for people. So starting from the left and moving right, we have a service called Elastic Beanstalk. You can think of it very much akin to a platform as a service type tool where you throw your code into Elastic Beanstalk and it helps build out a highly available, automatically scaling infrastructure for you, ties in things like ELB and auto-scaling groups and EC2 instance configuration. And all you really need to do is just toss your code at Beanstalk, and you have a couple of different parameters that you need to select up front, and then again, it just builds that for you. Really great tool for those who are getting started new on AWS, or if you really want to be a little bit more hands-off with your actual infrastructure on top of AWS. The next service we have is something that we launched earlier this year called OpsWorks. OpsWorks is kind of similar to Beanstalk, although it gives you a bit more configuration and a bit more hands-on control involved. With OpsWorks, you actually define out different layers of your infrastructure stack. So a web tier, an application tier, a database tier, a load balancing tier, whatever it might be. You control those individually in OpsWorks, and it has different tools to help you deploy new code and provision those resources. It also ties in directly with OpsCode Chef, so the instances when they come up can help or can make use of Chef cookbooks to help deploy applications or configuration files or whatever it might be. So another tool that we have to really help make administration of services much, much easier. Further on the right here, we have CloudFormation, a service that I'm particularly very fond of. CloudFormation is a template-driven service that we have to help you deploy out your infrastructure in a very repeatable and controllable way. So you define these JSON templates that would define resources from EC2 instances to security groups to RDS instances to VPC subnets, whatever you could think of. And use these files to then modify and update your infrastructure, again, in a very, very controlled way. And so CloudFormation is a very powerful tool that a lot of organizations, as they mature in AWS, begin to make use of. And then obviously lastly is the ability for you just to manage raw EC2 instances, something that will definitely not work for you at scale, especially when you're dealing with the hundreds of instances that you would in an application that would be serving potentially millions of users. Going along with the AWS management tools, you also want to be thinking about some host management configuration tools. So again, I had mentioned how OpsWorks ties in with Chef. We do see a lot of customers using Opscode's Chef or potentially Puppet Labs' Puppet to do host-based configuration management of their instances. They both more or less do a lot of the same things these days. They're not too dissimilar. Syntax and some methodology might be a little different. But we really recommend that customers look into a tool like one of the two of these or one of the other ones that are very similar to these, things like Ansible or Salt. They really, really help you with managing and deploying the infrastructure that you have. And so you really want to spend time learning these services, understanding how they work and how you can best utilize them. And it's going to be really difficult for you to be able to scale on AWS without having one of these tools. So again, spend some time to get to know them and to build them into your infrastructure. So a quick review. Obviously, we've talked about a lot of different things today, a lot of different things that you need to think about when you're building for scale in AWS. Multi-AZing your infrastructure, again, one of the key core components of building on AWS, making use of those different AZs within a single region, making sure that you're evenly spread across them, either manually or via using services like Autoscaling and Elastic Load Balancer. Try to leverage as much as possible the self-scaling and self-healing services that we do have, so things like ELB, S3, SNS or SQS, Simple Workflow, or SES, etc., all the different services that we have here for this. Try to build in redundancy at every level. Right? Try to avoid any single point of failure that you might have in your application stack. And really try to think about how your components are talking to each other to make sure of that. Again, start with SQL. Seriously, strong recommendation from us. There's a lot of cool technology out there, but look at your organization and what you're doing and how you're using it, or how you're accessing your data and how your application might be accessing your data, and really pay attention to the kind of database technology that you end up going with. Move to NoSQL if it really makes sense. Again, really think hard and really fight hard to determine that is the right choice for you to make. Try to leverage managed or low-touch services as much as you can. Again, things like DynamoDB, where pretty much zero administration outside of provisioning of it, will definitely make your life easier as you're building out a new application or scaling a new site. Think really hard about SOA, splitting those individual application components and tiers that you have into individual components, individual services. Again, it's really the key to getting a really scalable infrastructure is making use of SOA. Try to use autoscaling once you're ready to, but try to make sure that you're definitely making the right choices in terms of what you're autoscaling and how you're autoscaling. You're going to want to make sure that you have good host-based configuration management tools in place, make sure that you've moved anything that is stateful off of those hosts, and are able to tolerate the failure of hosts based on autoscaling doing a downscaling action. Try to use automation tools in your infrastructure wherever you can. Again, both the ones that we provide and the ones that are out there from third parties. It's very difficult at scale to do this kind of stuff manually. I see a lot of companies waste a lot of time and resources in doing things manual when spending the time to learn an automation tool would definitely be helpful. And then, again, make sure that you have good metrics monitoring and logging tools in place. You can't make educated decisions without that data. And right from the beginning, try to have those tools set up. And if you can't run it yourself, you don't want to run it yourself, look at some of the third parties that exist out there that could do it for you, either in a hosted fashion or provide bundled software. And obviously, one of the most key important things here is don't reinvent the wheel. Don't spend time trying to build services on your own that other people might have for you, that the cost of building it could well outweigh the cost of using a third party. So putting this all together, we should be able to handle our golden 10 million plus users here. Again, it's all a little bit of those components. It's definitely a lot of working through whatever kinks you might have and making sure that you are on top of the data and what's actually happening inside of your infrastructure. Moving beyond 10 million users, to infinity and what goes on above this amount, it's going to be a lot of what we covered today, right? What's going to get you up above the tens of millions? Pretty much what we've covered today. Again, just kind of continually iterating on top of those patterns and SOA and really fine-tuning and performance tweaking of the things that might be going on inside of your infrastructure and your applications. Things that you'll definitely want to take into account and want to think about beyond, again, really fine-tuning of your application and really heavily SOA is maybe potentially looking at going multi-region. Again, we really don't encourage customers to think about multi-region up front outside of potentially maybe DR reasons. But again, multi-AZ inside of a region can usually help you out with a lot of that. You might potentially, when you're above 10 million users, need to start thinking about doing custom solutions. Think about actually building some of these components yourself that are very purposeful and tied down to exactly what you're doing and how your application works. And then also doing really deep analysis of your entire stack. So really looking at all the different components, all the different services, and really diving deep in exactly how each of those things are performing in order for you to really get the most out of them. So what are the next steps? We believe in putting as much information and as much documentation as we can publicly out on the internet, which is why if you go to aws.amazon.com/documentation, you will find very in-depth documentation for all of our services, get it started guides, best practices, things like that you'll find that are available to you. If you go to aws.amazon.com/architecture, you will find different architectural patterns, case studies, customer success stories of what they've been able to build and architect on top of AWS to handle massive scale operations. And then also aws.amazon.com/startups. For those of you that are from a startup that are listening in on the phone, again, lots of interesting case studies and references that you can build off of. We also encourage you to spend some time playing with our free tier. So aws.amazon.com/free. Almost all the services that we have are part of the free tier. It enables you to a certain amount of usage or capacity over a 1-year period, your first year as a customer. And it's a great place to just kind of get your hands dirty and understand how things work and get to turn some knobs and play with things a little bit. Also really encourage you to reach out to forums, really robust community there in the forum space to help you solve any problems that you might be having. Beyond that, we also definitely encourage you to look at signing up for support. If you are running a production application on AWS, it's extremely recommended that you are a member of a support tier because there's just so many different benefits of working with our support organization and them being able to help you troubleshoot things and help answer questions for how things work. And then lastly, reach out to a local account manager. If you don't have one of these, actually one of the best ways to get one of these is to message support and say that you would like to talk to somebody from the account team, and they could put you in touch with the right people based on wherever you are in the world, and also help you get in touch with resources like myself. And so with that, I want to thank you for listening today. We're now going to try to do some Q&A here for the next 30 minutes. I have a hard stop at 1:30 p.m. Eastern here. But thank you again all for listening. As Bowen mentioned earlier, the slides and also a recording of this will be available for you sometime in the next few weeks, and you should receive an email about that. But again, I hope that you all found this useful and learned something, and thanks again for your time. So 1 second here as I go through and try and filter through the questions here. There's quite a bit. Someone had asked earlier, is the latency between regions significant? I want to know if I have users uploading to S3 from US West and US East to a bucket in US West Oregon. Is the difference in latency negligible? So, latency is going to depend on a lot of things. You're really going to want to think about where the users are uploading from. What I've seen is that if you have people uploading, say, from a mobile device, it's going to be really highly dependent on the carrier, how close they are to a tower, where they are in any given space. And so that is actually going to be the bigger concern than you have versus any sort of latency that might be on our side. And so if you're really looking to shrink that, I've definitely seen applications where customers of our service will actually, based on where the device is loading the application from, actually point users to the closest S3 region to them. There's a lot of different ways that you could do this. Our Route 53 service has the ability to do latency-based routing, so you can actually, via a DNS query in the application, figure out what region they should be talking to, and then point the application at that endpoint. And then what you do with that data afterwards, I guess, is kind of highly dependent on your application. So that's something that I guess you would have to build into your application. Thank you for that question, though. Someone just asked the question of, when considering failover, are zones within a region physically separated? Yes. So availability zones are wholly separate data centers on wholly separate plots of land inside of a given region. They are 5 to 15 miles apart. Different power grids, different floodplains, different fault lines were applicable, different Tier 1 ISP connections go into each of them. So you should be able to think of them as complete equals inside of a region, and you again want to be building equally across them, with the idea being that any component in your application could fail all the way up to an AZ level, let's say, and hopefully your application could continue to live on. Someone asked the question of, do I have any suggestions in terms of dealing with Postgres or PostgreSQL? So right now today, we don't have a service that provides Postgres for you. We did actually just publish a white paper on Postgres. If you Google AWS Postgres white paper, you should find a link to it. It includes a lot of our best practices for running Postgres at scale on AWS. It's definitely something that we hear a lot of people about. A lot of people requesting, and so hopefully at some point in the future we'll do something with Postgres. Another question just came in. Any tips on code promotion strategies for application tiers or SOA components? Code promotion strategies. I'm not sure if this is referencing on the people side of things or on the application side of things. In terms of getting people to think about things, you really want to spend the time to get on a whiteboard and break out all the different flows that you have within your architecture, within your application, and think about how you could separate those out. So spend time with the developers and the product organization to think about how can we break apart this larger application and deal with those individual components. Hopefully that is hopefully that's what you were looking for with that question. Try to get some of the questions that were from earlier. So in terms of, someone said for metrics, do we have any suggestions for third-party providers? Again, I really encourage you to look at our marketplace. The companies that are listed on the marketplace have definitely been vetted by us. We've definitely been a part of understanding their solution and how well it can work for our customers. So there's really a lot of different options depending on exactly what it is that you're looking to do. And I just really encourage you to take a look there and explore a couple different options. Someone asked in terms of the self-healing clients that are written specifically for Elasticache. That's correct. Right now today, those clients only would work with Elasticache. They would not work with your own hosted Memcache, and it has to do with how the clients have the ability to talk to the control plane to find out what the new service endpoints or node endpoint names would be in part of an Elasticache cluster. Someone had actually asked here when I said, scaling 10 million users, do I mean the ability to serve 10 million at peak load? Kind of a fuzzy number in the title here. It could mean 10 million total users on your site. Could potentially mean 10 million at peak load. It really depends on what your application is, how heavy that is, and what's involved in your per user activity. But generally speaking, I think that the recommendations that we go through in this webinar, the architectural guidance that we provide is the kind of thing that, again, depending on your application, following these design patterns can get you to a very, very high level of concurrency, level of number of users, and all of that. A couple of people are asking very, very specific questions about their architectures. I unfortunately wouldn't want to go into anything really specific on this call. I definitely recommend that if you are running into issues with services or you're running into something that you don't think is quite right, definitely the kind of thing that you want to reach out to support about and see if they have some further guidance there. Someone just asked, what is the typical use case for cross-region architecture? So it depends. Sometimes it could be, let's say that you have a highly latency, highly latency concerned application where you need to, let's say, serve out things like online advertisements or be able to get data from points around the globe very, very quickly. And so that might be a place where you do want to end up going with a cross-region architecture where you are using, again, our latency-based routing potentially to direct traffic to the closest region. Other places where people might do that is for things like DR on a cross-regional level. Let's say that you have such an important application that you are concerned about, something horrible happening that destroys an Amazon region. How important is it your application to be available inside of another region? And that really comes down to a business need for that. And, again, adds a lot of complication to what you might be doing in your application. So someone asked here, can I go over what you mean by build service? Also, what services are available for metrics and logging? In terms of a build service, I don't recall exactly mentioning that. We don't really have anything that would build application code for you. We do have services that would build out infrastructure for you. So Elastic Beanstalk, where you push into it your code or your deployable application that you might have, it will stand up EC2 instances and autoscaling groups and ELBs and stuff like that for you. In terms of talking about services that are good for metrics and logging, so we do have a service called CloudWatch that is built in across many different components of our platform to help you gather metrics from things like EC2 instances or autoscaling groups or RDS instances, and you can use those metrics to help troubleshoot your infrastructure, to help understand what's utilizing parts of your infrastructure. And so that is probably the main service that we have to help with metrics collection and monitoring. In terms of host logging or application logging, we don't really have a service for that today. That's really where you would have to kind of leverage third parties or open source or enterprise applications, say such as Splunk, very, very popular tool on our platform. Right now, those are probably the best options. One second here. Someone actually asked the question here, are you planning to monitor amount of available memory inside of an EC2 instance? So the CloudWatch team actually has provided a bunch of scripts that you could use to run on your EC2 instances that will actually report that information. So if you go into the CloudWatch documentation, you will see that. The problem with things like available memory is that it is only a host-level based metric. So you would actually need something running on the instance to provide that to CloudWatch that you could monitor. So those scripts help you out. They're things that you could run as a cron job or just as a background process, and it will put that information into CloudWatch. Then you could potentially do monitoring or alerting off of that. Someone had a question about free tier. Does it backdate to when you start using the services? It actually backdates to when you open the account. So if you open the account, that is the beginning of your free tier. Someone asked the question of many of the diagrams show a the large-scale application just using a web layer directly accessing the RDS instance. When would it be a good idea to separate out your data layer into separate EC2 instances? So maybe having a middle layer application tier in between the web tier and the database tier. Really depends on your application. Makes as much sense, I guess, as it does, given whatever your stack might look like. Definitely didn't mean to discourage that type of a topology in this presentation. Really, if you have a middleware layer or some sort of a middle business logic layer that's interfacing with your database, it totally makes sense to put that on a separate tier inside of Autoscaling and potentially put an ELB between your web front ends and that application tier to help you scale horizontally to handle load. Looking for any other questions here. Still have just a couple of minutes if you want to try to submit things. Any other questions? Feel free to fire them at me. Going once, going twice. Any other last questions here? Oh, here we go. One question here is, can S3 snapshots be scheduled automatically from EC2? So right now it is not built into the platform itself today. There are some third-party tools that could be used to do this, or it's something that you would have to build yourself into doing that snapshotting. Another question here is, what do you mean by host-based configuration management? What does this do? So in this case, we're talking about something that would actually sit on the host, continuously running to help manage things like application configuration, the OS level configuration, any sort of application install. So tools like Puppet and Chef will actually run on your instances, and then you could continue to push down any sort of changes to them without having to roll out a completely new host or having to make those changes yourself. And so these can be very powerful tools to help you do broad-scale management of your infrastructure. Let's say that I wanted to take all of my, I had 400 Linux-based hosts, and I wanted to take those hosts and change, the LDAP config on all of them, right? So I'm looking at some managed way to do that. What these tools could do is help you do something like that. And that's a very kind of basic example, but it's really something that lives on the instance or on the host itself and helps manage the configuration. Now, we certainly have tools that can help you in the initial provisioning of those instances, things like CloudFront and Beanstalk. But in terms of the ongoing management, that's really where these tools play a role. And that's why tools like OpsWorks have Chef built into it, which kind of helps you with this. Someone asked the question here about, can I talk about the cost of the tiers, latency, for example. So in terms of the cost of the tiers, in terms of things like latency, I think it's going to be highly dependent based on what those tiers are made up of and what you're talking to, and in terms of what scale that you have here. Generally speaking, latency could be very, very low or very, very high, right? I mean, it depends on, are we talking about latency of database queries, or are we just talking of latency between two different hosts that have different parts of your application? A lot of different factors, from instance size to, are they in the same AZ or are they different AZs, to how good is your code and how quickly can it reply to requests. Generally speaking, between hosts in AWS, latency should be the same as they would be if they were in your data center on the same switch. Should be very, very low. Between AZs, you should be looking at maybe an additional 2 milliseconds above whatever you see in inside of a single AZ. So it shouldn't look drastically different when you're doing multi-AZ versus doing inside of a single AZ. Okay. So I was talking about a question here with promoting components, say, from test to production environments. I guess it really depends on your code deployment process, how you would handle or how you do handle deploying that code. And things like Beanstalk, they have the ability for you to have different environments, such that you could have a test environment that you do code deploys to, and then once it's been approved via, say, like an automated system or a manual process, you then allow that code to be deployed to production. You could do similar kinds of things with OpsWorks or with CloudFormation in terms of, let's say, referencing some sort of deployable asset that you have, maybe a zip file or an RPM or something like that, and taking that code and moving it from one environment to another environment. In general, again, SOA favors you really heavily here. Right? The lighter your service tiers are, the better that you can independently push out different features or new versions without affecting the bigger picture potentially of your application stack. Someone mentioned here about ELBs not having certain metrics and counts inside of them. Yeah, there are definitely things that are missing from certain services today. We're definitely constantly trying to iterate and build on top of our services, largely based on customer demand. So something that you may not see today, you might end up seeing in a couple months' time, or maybe sooner or maybe later. Again, kind of depending on what the demand is for that. Generally speaking, a lot of times you can garner metrics from other parts of your application, pump them into CloudWatch, and use them for things like autoscaling, other sorts of alerting. And I actually am going to have to make this be the last question, unfortunately, here, as we're coming out to the bottom of the hour. Why don't I recommend multi-region deployments? With a globally distributed user base, it would seem to make sense. So yes and no. So it really depends on what you're talking about with this user base. If you have a simple web application where most of the interfacing with it is let's say the end user is getting, say, static assets, and there's maybe just a little bit of data proportional, again, to those static assets that's going back and forth across the wire, you can actually perform quite well, again, making use of a CDN to serve out those static assets, making use of something like Route 53 to lessen the amount of time the DNS queries would take, and then serving them the data directly from a single region. I think it really, really depends on what your goals are for latency and request time to those end users. Obviously, also depends exactly on what the application is, but usually speaking, the amount of data that's probably coming out of the region is hopefully a lot less than the total picture of what you're serving out to those users. Again, assuming that you can put some content into CDN. And I think that stands true for probably 90+% of web applications in existence today, at least the ones that I've seen and dealt with from both small startups up through enterprises. Very rarely do you have to go multi-region, again, unless you're at a very, very large scale or you're just extremely, latency sensitive. So with that, we're pretty much at the bottom of the hour here today. Again, I want to thank everyone for participating. Really want to thank you for these questions. I hope that everybody has had some good takeaways from this and that this was worth your time. Thanks again, and have a great day. And as we mentioned earlier, again, this presentation and these slides will be available online and sent to you guys over the next couple days, if not the next week or so. Thank you.
Thank you, Chris Mons. Reminder for everyone, please click on the purple URL widget so you can have a chance to fill out the survey before we close out the webcast. So I'd like to extend a special thank you to our presenter today, Chris Mons, and all our live attendees. Thank you, everyone, for joining. Have a rest of your day. Thank you.